There is a planet, 11 light-years from Earth, that solved every problem we solved, and none of them the same way. Its designation in our catalogue is AEGIS-4, a terrestrial world, roughly Earth-sized, orbiting an M-dwarf star, a red dwarf, smaller and cooler than our Sun, but far more active, more violent, more present in the daily life of everything that lives beneath it. AEGIS-4 has liquid water. It has a nitrogen-rich atmosphere, twice as dense as Earth's, pressing down on everything that lives there. It has a liquid iron-nickel core, larger, proportionally than Earth's, spinning faster, generating a magnetic field so powerful that the auroras on AEGIS-4 are not the quiet curtains of light that occasionally appear at Earth's poles. They are permanent, a constant roiling, planet-wide electromagnetic event, visible from orbit as a shimmering skin of charged plasma wrapped around the entire world. Beautiful from a distance. And from the surface, the single most consequential fact in the entire history of this civilization's technological development. On Earth, the development of electrical technology followed a path that felt, in retrospect, almost inevitable. Copper wire, electrical current, the telegraph, the telephone, the generator, the motor, the transistor, the microchip. Each step building on the last, each discovery unlocking the next. A chain of development, so linear and so logical that it is easy to assume it is the only chain, the only path from fire to computation. It is not. On AEGIS-4, the first civilization to smelt metal discovered something that every subsequent generation of engineers would spend their entire careers working around. Long pieces of metal in the presence of the planet's permanent geomagnetic storm become circuits. Not useful circuits, dangerous ones. A copper wire stretched more than a few meters on the surface of AEGIS-4 in the presence of its magnetic field does not carry a controlled current. It carries whatever the magnetosphere decides to put through it, which is, depending on the storm intensity, anywhere between a mild tingle and an arc discharge capable of igniting anything flammable within 2 meters. The early metallurgists learned this painfully, repeatedly. The engineers who came after them didn't try to solve it. They worked around it, completely. If long metal conductors are lethal on this planet, then this planet will not use long metal conductors. Simple. And that is the foundation of everything that followed. The Coandă effect. It was documented on Earth in 1934 by the Romanian engineer Henry Coandă. The observation that a fluid jet emerging from a nozzle tends to follow a nearby curved surface rather than continuing in a straight line. On AEGIS-4, this effect was not just discovered, it was engineered around for centuries before anyone understood why it worked. The first fluidic gates, devices that used one stream of pressurized air to deflect another stream of pressurized air, routing it down one channel or another depending on the input, were built by engineers who simply noticed that air, under the right conditions of pressure and channel geometry, behaved with a consistency that metal could not be trusted to provide. An airstream does not arc. An airstream does not spark. An airstream does not become a lethal circuit in a geomagnetic storm. It simply flows, obedient to pressure differentials and channel geometry in a way that the magnetosphere of AEGIS-4 has absolutely no ability to disrupt. The first fluidic gate was the size of a workbench. It could perform one logical operation, route one airstream based on the presence or absence of a second. It was, in every meaningful sense, a transistor, made of ceramic, powered by compressed air. producing no electromagnetic signature whatsoever. The engineers of AEGIS-4 had found their microchip. A civilization runs on energy. On Earth, that energy moved through copper or aluminum wire at the speed of light, from power station to home to device. On AEGIS-4, it moves differently. It moves as steam. Deep beneath every city on this planet, boreholes descend into the volcanic crust, into the superheated rock and subterranean reservoirs that the planet's active geology maintains at temperatures far above the boiling point of water. Those reservoirs are tapped. The steam that rises from them is captured, pressurized further, and fed into the mains. The mains are the circulatory system of every city on AEGIS-4. Massive conduits, some as wide as subway tunnels, running beneath every street, carrying supercritical steam and high-pressure nitrogen at pressures that would destroy any structure not built specifically to contain them. They do not hum. They do not buzz. They rumble. A subsonic vibration felt through the soles of every foot on the surface above them. The constant, reliable, geological heartbeat of a civilization that learned to drink directly from its planet's interior. Homes tap directly into the pressure main through metered valves. Appliances run on tiny pneumatic turbines, spinning at high speed on steam pressure, converting that pressure into mechanical work with an efficiency that increases rather than decreases as the atmospheric pressure above them rises. The dense atmosphere of AEGIS-4, which would make a human visitor feel as if they were standing at 30 meters underwater, is not a problem for this civilization's energy infrastructure. It is an advantage. Higher ambient pressure means higher pressure differentials available for work extraction. The planet's own weight is part of the engine. Communication on a planet where the atmosphere scrambles every electromagnetic signal above a certain frequency required a different medium entirely. Two of them, in fact. The first runs underground. The pneumatic tube network of AEGIS-4's cities is not a quaint relic of an earlier age. It is the primary data infrastructure of a civilization that has no alternative. Vast underground vacuum networks, laid alongside the pressure mains, shoot capsules through ceramic-lined tubes at speeds approaching 100 miles per hour. Inside those capsules, punched paper memory tapes, encoding data in physical wholes, present or absent, 1 or 0, the binary logic of a civilization that arrived at the same mathematics as ours through an entirely different physical substrate. Or fluidic cartridges, sealed ceramic modules containing pre-programmed air channel configurations, plugged directly into a receiving fluidic processor and read in seconds. Physical data, traveling physically through tubes beneath the feet of every person on this planet. The latency is measurable in minutes for cross-city transmission, hours for intercity. This is not just a limitation. It is simply the speed of their world's communication. For long-distance regional communication between cities across the mountain ranges and ocean straits that separate them, the pneumatic network gives way to something stranger. Infrasonic resonators, massive steam-powered acoustic horns built into the bedrock of high ground, emitting vibrations far below the threshold of hearing. Vibrations that do not travel through the air, but through the rock itself, through the bones of the planet, received hundreds of kilometers away by mechanical diaphragms bolted directly to bedrock, translating the planet's own vibration back into signal. They do not broadcast through the sky. They speak through the ground, and the ground of AEGIS-4 carries their voices faithfully at the speed of seismic propagation across the vast distances of the planet. Stand at the edge of a city on AEGIS-4, and what you see is not what you expect. Not because it is alien, but because it is so precisely, so inevitably, the product of its physics. The skyline is dominated by cooling towers, massive structures designed to shed excess heat from the pressure mains below, their plumes of condensed steam rising constantly into the dense atmosphere, caught by the aurora light and turned amber and violet against the heavy sky. At irregular intervals, timed by pressure relief cycles, relief valves across the city open simultaneously. The sound is like 100 steam locomotives releasing their brakes at once. A thunderous, train-like blast of vented pressure lasting 3 to 5 seconds that rattles every building, every window, every piece of loose ceramic on every workbench in the city. The residents do not flinch. They have heard it every day of their lives. The streets are paved in ceramic tile, not stone, not asphalt, stone chips and cracks in the pressure wave of a relief event. Asphalt, a petroleum product, would not survive the sustained surface temperatures produced by steam venting from the mains below. The buildings are of heavy ceramic construction, with triple-sealed windows and pressure-equalized interior environments. It is not a hostile city. It is a city that wears its physics on the outside. Every design choice, every material selection, every valve placement, visible, legible, explicable by the forces that shaped them. A city that cannot lie about what it is made of. There is a question that this civilization forces us to ask. A question that seems obvious once you have spent time understanding how AEGIS-4 works, but that is surprisingly easy to miss if you approach this world with the assumption that intelligence leads inevitably to the same technologies. The question is this: is there a universal path from fire to computation? Or does physics determine everything? On Earth, some tend to assume the former. Some assume that any sufficiently intelligent species, given enough time, will discover electricity, will build circuits, will develop radio, will create digital computers, will eventually arrive at something that looks broadly like us. AEGIS-4 suggests otherwise. The engineers of this planet are not less intelligent than ours. Their fluidic computers, running on ceramic plates and compressed air, can theoretically perform every logical operation that a silicon chip can perform, more slowly, in a larger physical footprint, with probably power consumption that is probably less efficient. Their pneumatic data network has latency measured in minutes rather than milliseconds. But it has never, in its entire operational history, been disrupted by a geomagnetic storm. Not once. And the magnetosphere of AEGIS-4 has no idea what to do with any of those things. Intelligence found a path. Physics determined which one. And the result is a civilization that is neither ahead of us nor behind us by much, but almost perpendicular, solving the same problems, using different tools, arriving at different answers that are, in every meaningful sense, equally correct.